Using humic and fulvic acid as a chelator or as a pusher, we call it in layman term, to be able to remediate the accumulation of heavy metals in the rice production. Here we can tell from here, we'll start off right away because 15 minutes goes really fast, and I'm like this gentleman that spoke to me before. I have the gift of the gab and I can speak a lot. So here we have on the left, we have an example of a graph which is given to us in the kilojoules to be able to show how is rice important into everyday life, into everybody and all over the planet. Doesn't make a difference if you are Asian or if you are English or Caucasian, that everybody eats rice. So to us, it was very important to address this situation. We can tell here in Korea, the average annual consumption of rice per person, 61 kilograms in 2018 from the statistics. I will move on right away to the next point because things go fast. Current situation. Several studies have this month said that rice shows a persistent presence of heavy metal, lead, cadmium, inorganic arsenic, and mercury. As you can tell here on the graph to your left, there are levels which are obtained through testing that is more than above what is tolerated for human health. How could I say human health, proper human health? In a sense, we are really in a sense polluting ourselves. Known to be cancerogene, heavy metals in food source can negatively impact the respiratory and nervous system, contaminate the environment, become concentrated as they move up the food chain through biomagnification. I'd like to take a moment here for this word. Biomagnification is very important. 10 years ago, it's something we didn't know. We didn't have a word to describe what would happen. What we're trying to tell you by biomagnification is that heavy metals are cumulative through the food chain. Meaning what? The plant has a certain level, the animals another level, and since we are at the top of the food chain, we'll be the ones most contaminated. That is true with heavy metals, and that's also true with other phytosanitary can be used in agriculture, like pesticide and herbicide and stuff like this, or nicotinoids. Okay? Our growing concern for us at ALC and all that is topsoil loss. We had a third of the world's land and several degraded and fertile soil is being lost to the rate of 24 tons per year. I think everybody knows that we need to address. I don't think I'm telling you anything new. Heavy metals here, movement of heavy metals from soil to plants represent the main source of human exposure. That is why we are, since the pollution, we are the last one on the food chain. That's why we are the most polluted in the food chain. Chemical additive evidence of several studies show that chemical herbicide and insecticide can adversely affect the entire food chain, which is basically what I was telling you before. The artworms, which are very important, what we've noticed in our studies and what we've done is that every time we saw soil pollution being very, very high, the earthworm count would diminish drastically to the point of going almost only 70 kilos per acres, which should be 7,000 kilos per acre. Okay? Now, can we decrease the uptake of heavy metals in plants organically during the cultivation period? That is a good question, and I will tell you yes, we can. What can be done? As we can tell here, we have a humic acid molecule to your left, and what can be done? What can we do to try to help and prevent these heavy metals to go up into our plant, into our rice, and to prevent them from coming into our bodies? As you will know, it's very difficult to take heavy metal, metallopatinoids, I'm sorry about my French, sometimes it's a little stuck. It's very hard for the human body to pull it out or chelate it, okay? Increase soil organic matter to balance pH levels and elevate the diversity of beneficial microorganisms. This increases the composition of soil minerals and breakdowns of inorganic monoids. Obviously, if the soil is healthy and the soil has a natural microbiome which is working very well and which is doing what it's supposed to be doing, which we call a topsoil, then we will have a decreased effect on the metallopatinoids. All right? They will not find an environment where they can live properly. They will get degenerate. Supplement with humic and fulvic acid. Humic and fulvic acid are complex carbon compounds that act as a strong natural chelator, I was talking before, of harmful toxin. They're also powerful antioxidant, fungi, inhibitor, and enhancer of uptake of essential nutrients. Limitation, yes we do. Humic acid as a passive element, as a singular element, fulvic acid as a passive singular element, has its limitations. What do I mean by that? That the humic and fulvic acid has a slow and long-term solution to decontamination, yes. But if we use it in the long-term decontamination process and we keep adding the tonnage that we need through the field or the rice field and stuff, we're gonna end up in the same point as what they did when they tried to use chemical, which was be bioaccumulative, once again, but in another negative way where we're gonna stop the soil from actually being fertile and fermenting and decomposing himself like it's supposed to do in the part of the topsoil. The issue with the long-term chelating can create deficiency in large target medium, which is true, because anytime you try to chelate, every time you try to pull out, if we only just pull out, we end up developing what we call a deficiency in the system. Whether it be a plant, whether it be a human or an animal, we have noticed that every time we try to chelate them with just the humic acid and the fulvic acid, we end up having a deficiency in the nutrients in this and that, almost a bit like a mild anemia, all right? Limited viability for industry scale. So what did we do? We knew we had a problem. We wanted to help, but we knew that these solutions here long-term would be another problematic. What did we do? Science meets nature. Develops after 5 years of R&D, a more complete nanotized molecule was needed, formulated by fermentation biotechnology. Since we wanted to work into organic, we had to find a way to build a molecule and also to nanotize the molecule. So once we build the molecule, it wouldn't be gross and complex, okay? A molecule that can chelate toxin and replace the void with positive elements such as vitamins and important micro and macro elements. And yes, yet still active and stable, powerful requirement requiring only small dosage. The problem with the humic acid, huge amounts of tonnage are needed to be able to do what we want to do. And also it takes a very long time. If you wanted to do something in the human body and chelate metalloproteinoids, it's anywhere between 24 to 36 months. It's almost 3 years to be able to achieve what we want to do. It was very lengthy, very too long. So we figured, okay, can we make a molecule that would speed up that process, that would increase the job that it was supposed to do? Obviously, we found it in probiotic, humic and fulvic acid, sea kelp and molasses. What we had the idea to do is to build a molecule that was complete, and instead of creating carence or creating deficiency, the molecule would end up being very easily just already prepared to exchange, meaning I will take out the metalloproteinoid and I will replace right away by whether a BRICS content or whether a micro or micro or macro element. Enhance viability, which is what we want to do. Here I'm going to show you an example of what type of, how much kilos you would need per acre of humic and fulvic acid to create the nutrition to try to chelate or chelate the metalloproteinoid and prevent them from coming in to the plant into the rice. It is creating a nutrition deficiency. It's a passive molecule. It takes a lot, not feasible for long term. Now, with our new molecule that we developed at ALC by Innovation, through our process and our integrated process of nanotization and all that, we're able to do the same thing, the same job we want to do, but achieve it with only 500 grams of acre of our molecule instead of 2 to 15 kilos. By doing that, that's when we found the magic point. That's when we found the point of entry. We said, okay, now we got something. We can do all the work we want to do, but with such a small amount of product being used that we're not creating a new problem. Instead, we are fixing. Here's an example of a decontamination test. Obviously, as you can tell, in Canada, we have no rice, so I cannot show you data on studies of rice. I'm really sorry. But I'm going to show you something that is very similar into what would be a contaminated soil and how we were able to, I would say, alter this manure pit that we're going to see right now, which is cow manure. As you can tell, the untreated manure pit, you can see a lot of the solids are still there. We see a bit of liquids. We have about 1 million liters, which is present right now in this farm. 14 days after the treatment with our molecule with ALC, as you can tell right away, there's a huge development of oxygenation that's been done. There's a breaking down of the organic matter that is there to liquefy it and to prepare it, better prepare it for the farmer to install onto the field. Another example, here as you can tell is a different picture. You can tell it's the same bin, but just different after 40 days. Increased oxidation in liquid matter and accelerated exposition of the dry matter is basically what we did with this. Now here are some results of the test. Prior to the application, as you can tell, we have certain levels of nitrogen, phosphorus and stuff, which is really in a sense the elements which are important to farmers, because farmers' manure and stuff are used to re-put organic matter onto their farmland and at the same time also create nutrition. As we can tell here, 14 days after the treatment, things have changed. Number one, we see that dry matter content is reduced by 1.1%. The total of nitrogen available has stayed the same, meaning what? Nitrogen is evaporated daily. If you don't stop it from evaporating in a manure pit, it will decrease as the day goes by. We're able right now to prove that we have fixed and stopped the nitrogen from evaporating into the atmosphere. Ammoniacal nitrogen has 10 we all know the number, ppm, helping prevent field burn and acidification of the soil. Very important here that you can tell onto the second line. Phosphorus pentaxide, blah, blah, blah. Once again, you see, we can tell just the chemical when the cumulative is reduced by, it's not small, it's a very small number. But if you do it on a large scale, we're really making an impact in a sense. Concentration of organic matter was low review application and transformation of the matter through fermentation. As we can tell, having bacterium present into our molecule helps and kickstart the natural fermentation of the manure. In the carbon, the nitrogen ratio shows a reduction of the evaporation of the nitrogen to the environment, which to us, this was a success. We've done a lot more tests, obviously. Here I wanted to use this one to focus. We have a lot of other things that were very, how could I say, relevant to what we did today, but in a sense, we wanted to focus on just that to bring you guys, I could say, an understanding that what we did by developing these molecules, that we've realized that if we want to achieve, want to do something, if we want to depolluate the human body safely without creating currents and stuff like that, or whether it be a soil, a plant, or an animal, it was all true in the same thing, that we need a new molecule to be able to do that. Obviously, humic acids have been studied for years. I am sure some of you guys have already seen some studies and stuff to Europe, maybe stopped around 2008. We carried on. We went from 2008 and kept carrying on with the element. We thought there was potential, but we knew there was problematic also with using just humic acid as a chelator or as a cleaner is okay. I'm going to try to use as much as I can layman term, I'm sorry, to be able to make sure it communicates to everybody. Did I do good? Am I in my 15 minutes?
You're safe.
Wow, it's a miracle, because I would give you the gap. Usually I can go on and on. I'm really sorry. Thank you, people. I would go on to questions if you would like now.
All right, yeah.
Thank you. Any questions?
Sorry, I'm just curious because it sounds like it's an agricultural product, and I was wondering if there's any testing done on like human safety, like because you're trying to remove it.
Absolutely,
right.
I can tell you right now, we have the molecule. Right now, we're launching the 1st of July, 2 pills for humans. One for Mr. and Mrs. Everybody, and one for the high level athlete. Absolutely, it's been done many times, and overall, all the bacteriums that I use, that I built, that's my specialty. I built all the bacteriums that are singular to the usage of what we do. Have all been tested for the Canadian and the American market. They are totally safe to use. Absolutely.
That's already approved.
Already approved, sir. Yes.
You mentioned that you're going to reduce down to about 500 grams per acre.
Yeah.
And is that cost effective?
It's very cost effective. That's why we do it. Part of our program was to address the fiscality of the farmers. That's why we did it. When you think of the big kilotage that is needed, it becomes not feasible for the farmer, for the end user. So what we had to do is create something that was going to be so much more effective, but at the same time, like you said, cost effective. Every invention that is built at ALC Bioinnovation first start with pricing and feasibility. We come from reverse engineering, so you have to understand we have a different way when we invent or when we research. We start at the end, and then we move backwards through the box to be able to develop something that is necessary. But we always keep in mind fiscality and the needs of the end user. I always said, you can have the best invention in the world. If it's so expensive that only 3 people can buy it on the planet, what are you doing? Well, you're wasting everybody's time.
Right.
Good question. Thanks. Don't be shy, guys.
Does this matrix have greater adsorption capabilities, or how can you spread less and still have the same?
By polarizing. We polarized all our molecule in ion negatives, if you would like to know. The fact that it is a molecule that is polarized, it's so much more reactive, it's so much more active. What we've seen in plants and everything else, the acceptance and the bioavailability that we create is really, really, it's out of this world. It's never been seen. Translocation is what we do best. Translocation is a word to tell you how the nutrients, the N, the P's, and the K's go through the plant and how they're going to travel up and down through the plant. That's what we do the best. And the hardest thing everybody has to do when they develop a supplement or fertilizer is to have a proper translocation through the plant. Especially now that you think that when we deal with the OMG corn, OMG soja. It's very difficult because when we first started testing 8 years ago, we realized that certain elements, due to the fact that the plant was altered, could not travel through the plant, due to the fact that the plants, the way it was built, didn't give the ability to recognize, take it, the element, take it and bring it off. And that's why we're able to make a transporter which is universal. Our molecule is universal, whether you're a plant, an animal, or a human. It will transport itself, it will go to where it's supposed to do and do the job it's supposed to do, which is to chelate and replace.
Including last question. So is there like a time-dependent efficacy changes, or like is it not the part of the concern?
Not even. It's really, in a sense, once a molecule is transformed and stable, it's very, very stable. As soon as it exposed, obviously, to humidity and all that, it triggers itself. It's reawakened. The bacteriums and all that start and start doing its job. Is it heat sensitive in a sense when it's in that form? Like my friend here, yes, I do have points of tolerance to the fact of the presence of bacterium in it. I cannot take my jar of, let's say, my product, put it out there to the sun at 45 degrees, 40 degrees, it's not going to work. We're going to have some deficiency of the molecule and degradation of the molecule. But if it's kept in a dry, cool place, very standard, because we have to build it for farmers and everything. Obviously, not all farmers have, like us in the lab, a controlled environment and this and that. So yes, we did do it so we can be in-field tested. It's already in-field tested. We've done all that testing and people appreciate, how could I say, the simplicity of the utilization.
One more question.
Sure.
Would you distribute this as the over-the-counter kind of
No.
nutritional medicine, or?
Right now, for humans, it is over the counter. The pharmacy of Canada and all that had asked us to make RX and develops because we are developing right now. We have to just put it out to market, but we also have a pill which controls Crohn's disease, and we're able to actually cure it and stabilize it, and also with irritable bowel syndrome. So yes, those products most likely will end up being RX products, like yours, what you presented to us this morning. But right now we start with an OTC. For the agriculture and all that, yes it is. The idea is to create an OTC, but since our molecule is very different and we have programs on how to utilize it properly, on how to reduce the usage of chemicals and NPKs when they're farming, there is a process that comes with it. It's not just a product that we sell them a process and a product. We follow the customer through his transition all the way through to where he wants to get. The idea is that we can take very easily a customer and say, well, you want to reduce your NPKs, your chemical usage up to 70%, 80%, it is possible. We can do all the job we're doing right now on this planet, agriculture, with 20% of those NPKs, and the rest can be supplemented with our molecule and other amendments and stuff that is part of what the plant needs.
All right. Thank you.
Thank you very much. Thank you guys. Thank you for listening to me. Sorry about my French. Merci doctor. Thank you very much.
Okay, we have now the third speaker.